Number 1 is on the board. Number 1 through 5, well 4, actually all it wanted you to do was combine the terms that were alike. Well, not combine them, it just wanted you to identify. Do you even know what like terms are? So that once we get to number 5 through 12, then you're able to add or subtract them. I told you that a good thing to do would be to use highlighters or different colors and circle your like terms in different colors, or to use different shapes and put like circles around all your A's, triangles around all your A squares, just different ways that you could identify. So whatever way you chose, that's what you're using now. 3A should have been like with 5A. The definition of a like term was the fact that it had the same variable raised to the same power. It does not matter what the coefficient looks like, because that's the one that you're going to add or subtract. But you have to identify the ones that have like terms before you can add or subtract. And that's what 1 and 4 were wanting to see. Your B squares would have been the same. So these two were both B squares. You did not have another B cubed, and you did not have another whole number. So there was nothing in the rest of that that said this one had a match or this one had a match. These were the only like terms for number 1. So check your work, please. We had enough difficulty with it yesterday that we're going over it again by going over what you did, and then you'll have another practice attempt today with the sheet that I'm going to give you, and we're going to do the first one on the sheet together. When you look at number 2, you had x's raised to no power, x's raised to no power. Those two are like terms. Again, the definition for a like term said they had to be the same variable raised to the same power. And you wrote that definition yesterday in your notes if you took notes. You have x's raised to the 4th power, x's raised to the 4th power. Those two are like terms. Then you had x squared, or x's raised to the 2nd, x's raised to the 2nd. So for number 2, you had 3 sets of like terms. Any questions? For number 3, you had n's raised to no power, n's raised to no power. Just n's. M squared. You did not have any more M squares. It did not have anything like to match it up with. N squares. You did not have any more N squares. So that one did not have a match. N's raised to no power, N's raised to no power. These two are like terms. And for your whole number did not have another term that was like. Any questions about number 3? Because these two are the only sets of like terms in number 3. Number 4 was the last one that only wanted you to identify, and then starting with number 5, they were asking you to combine. So we were actually simplifying 5 through 10. 11 and 12, you had to come up with your own expression and then simplify it based on what it asked you to do. For number 4, you had s's raised to no power, s's raised to no power. Those two were like terms. You had s's raised to the 4th power, s's raised to the 4th power. Those two were like terms. S is raised to the 2nd power, or s squared. You did not have any other s squares. You can't circle it, you can't color it, you couldn't pair it up. Then you had whole numbers. You had a whole number 5. If it does not have a variable, it's a whole number. Or it could be a decimal, or it can be a fraction. We're going to go that way too, but since we're just starting, everything that you're going to see right now are whole numbers. So the whole number 5 and the whole number 2, they did not have variables. They are like terms. Any questions before we start simplifying at number 5? Okay, number 5. The first thing you would have done is put a 1 here so that you understood that that's 1p. They're not going to write the 1 for you. Every time you see a variable by itself, the coefficient is understood to be 1. So I had 2p and 1p. That's the only thing that was like in this expression. So those are the only things I can combine. If I have 2 p's and I take a p away, how many p's do I have? 1 p. And again, I'm not going to write a 1 in front of it because it's understood when I see a p there, it's just 1 p. Then I had add 22q squared, and there's nothing that I can compare it to or combine it with. There's no like term. It's left by itself, so you just drop it. That's the answer to number 5. P plus 22q squared. Number 6, it started with no coefficient there because it's understood to be 1. We have x squares here, x squares here. This is not an x squared. It cannot be combined with these. It is, however, a whole number. What is 4 times 4? 16. So you were supposed to at least turn that back into 16. But there's no other whole number to combine it with. That's the only whole number. So if I have 1x squared and I add 3x squares, how many x squares do I have? 3 plus 1 is? I have 4x squared. Because 16 has nothing to combine it with, then you just drop it. You rewrite it. So the answer is 4x squared minus 16. Do you know why though? Now if you got 4x squared minus 4 squared, that 4 squared could be simplified down to 16. It's 4 times 4. You wouldn't leave it in that form as 4 squared. Here we have n to the 4th. There are no other n's to the 4th in any of these terms, so we are just going to rewrite n to the 4th because we know that it would drop. Then I have 1n cubed and I have 1n cubed. But if I had 1n cubed and I took 1n cubed away, how many n cubes do I have? None. So they just canceled each other out. I don't even write it. You don't write 0 there. You have no n cubed, nothing goes there. Now I have 3 n's, subtract 1 n. If I have 3 n's and take 1 n away, how many n's are left? I have 2 n's left. That's the answer to number 7. Any questions about that one? Let's go over here to number 8. I have A's, 4 A's, 2 A's. Those are all my A's. I have B's. I have 4 B's and 5 B's. And then I have whole numbers. I have a 2 and I have a -1 or subtract 1. And if you keep change, that is a -1. Either way you solve it, you know what it's going to be. So I would start out by combining my A's. If I have 4 A's and I take away 2 A's, how many A's do I have? I have 2 A's. If I have 4 B's and I add 5 B's, how many B's do I have? 9 B's. And if I have 2 and I take away 1, how many do I have? 1. That's the answer to number 8. You identify all your like terms first, just like we did up here. Then you start from the left and you start combining those things that you said were alike. And how do I know how to combine them? The sign, you notice that I'm circling the sign in front of them every time. That tells you how to combine them. Number 9, I have M squares. I have M squares. In that problem, that is the only thing that had like terms. I did not have any other n squares. I did not have any other n's. And I did not have any other whole numbers. So these are the only ones I can combine. How do I combine them? I subtract them. If I had 32 m squares and I took 12 of them away, how many do I have left? I have 20 m squares left. Now I still have 14 n squares, I still have 5 n's, and I still have 3 because they had nothing I could compare them or combine them with. So even though this is simplified, it isn't simplified much because I was only able to take 2 down to 1 in a thing with 5 terms, in an expression with 5 terms. This one was the last one before the word problem. If I had h squares, here are h squares. There are no more h squares. I have g's here, and I have g's here. What is 2 squared? 2 times 2. What is 2 times 2? 4. So I have a whole number here and a whole number here. So I could combine every term with something in this expression. So if I had 2h squares and I took 2h squares away, how many h squares do I have? None. They canceled each other out. That's 2 sets of 0 paired h squares. If I have 3 g's and I added 4 g's, how many g's? 7 g's. And if I had 4 and I took away 3, how many do I have? 1. That's the answer to number 10. Now 11 and 12 were only a tad bit harder because you had to come up with your own expression from the word problem. Now, it says to write an expression for the perimeter. What is the perimeter of an object? The outside edges. It is all the way around it. It's if I'm adding up all the sides. If I want to put a fence around a yard, that's perimeter. If I wanted to put a chair rail around the room, that's perimeter. So you had to actually add up all the sides. It says combine like terms in the expression. So if we wrote an expression, we have 6b plus s is side 1. Then I've got to add 5s minus 4b, which is side 2. And then I have to add 2s plus 5, which is side 3 of that triangle. Now, once I have written the expression, it doesn't look any different than any one of these we've already done. All you had to do was add these 3 sides. You had to write it out. Once you wrote it out, you're going to do the same thing. All of my v's are here. I can combine these. There's one s. So I have an s here, I have some S's here. I have some S's here. So I have S's I can combine, but I do not have another whole number that goes with this 5, so it stays there. Now, if I have 6 V's and I take 4 V's away, how many V's do I have? 6 minus 4, 2 V's. If I have an S and I add 5 S's, that's 6 S's. And if I add 2 more S's to 6 S's, how many S's do I have? 8 S's. And then I have this 5 hanging out, and you have to include it even though it doesn't have anything to combine it with. So that's the answer to number 11, 2V plus 8S plus 5. Now again, I can't solve it. I don't know what V and S is. If I knew what V and S was, like in the last lesson, I could give it an answer. I could evaluate it. But if I can't, then the best I can do is simplify it. Write an expression for the combined perimeters of the figures to the right. So now we're adding up the perimeters of the rectangle and the square. So in a rectangle, opposite sides are congruent, or the same, or equal. So in the rectangle, you would have 2A, and you would have 2B plus 2. B plus 2, B plus 2. That's the perimeter of the rectangle. The 2 short sides, the 2 long sides. Now I have to add to it the square, and in the square, all sides are the same, and all sides here are 3A. So I have 4 sides that are 3A. 1, 2, 3, 4. Tomorrow we're doing the distributive property, which will make writing something like this a lot easier. But after you do the distributive property, it breaks it down to something like this that then you have to combine like terms with. So if you're not understanding this, then tomorrow you still won't be able to do this, because this is still part of tomorrow's lesson using the distributive property. So it's important that the practice you get today, if when we finish this one and do the first one on your sheet, if you're still not understanding it, that you start asking some questions. Now, these are our 2 combined perimeters for this rectangle and this square. We have an A here and an A here. We have a B here and a B here. And so now we have to circle all of our like terms. So we have A's, and then we have B's, and then we have whole numbers. Everything could be combined. There wasn't just one thing like the 5 here that didn't have a like term to combine it to. Everything can be combined. So if I start with my A's, if I have 1A plus 1A, that's 2A's. 2A's plus 3A's is 5A's. 5A plus 3A is 7A. Nope, 8A, sorry. 8A plus 3, 11A. Plus 3 more is 14A. So that's 1, 2, 5, 8, 11, 14. We had 14 A's in that expression. Questions about that? Now our B's, we had 1B, 2B's. Adding them. 1 plus 1, 2B's. Then we had 2 plus 2 is 4 for our whole numbers. So this is the answer to number 12. Any questions about that? Okay. I am going to pass out the practice sheet for today, give you some explanation of some of the direct